we're going to practice multiplying and dividing rational expressions. So for multiplying, the first thing I'm going to look for is a number in the numerator position and a number in the denominator position that have a common factor. So I noticed that 5 and 25 have a common factor, and 5's in the numerator, 25's in the denominator, so I can divide those by 5. So when I divide those by 5, I'm going to rewrite my product here, 6k over 5, because 25 divided by 5 is 5, times, well, 5 divided by 5 is 1, so this is 1 over 7k to the 4th. Now I'm ready to multiply straight across. So if I multiply straight across, 6k times 1 is 6k, and 5 times 7k to the 4th is 35k to the 4th. Now I need to use this rule right here, which says if they have the same base and you're dividing, you're subtracting the exponents. So this is k to the 1st and k to the 4th. If I subtract 1 minus 4, I do get a negative 3. That negative 3 just means the k is going to land in the denominator. You could also think of it as expanding. If I have 1k in the numerator and 4 in the denominator, I would be left with 3 in the denominator if I cross out that pair. So my final answer then is 6 over 35k to the 3rd power. So again, I combine my base k here using the rule, and when I subtract, I got a negative, so that means the k landed in the denominator. So for dividing, you have to remember how to divide fractions. The first thing you need to do is multiply by the reciprocal of the second fraction. Reciprocal means flip this fraction or interchange the numerator and denominator. So let's rewrite this as multiplication. So 2a to the 3rd over 9, and instead of dividing, we're multiplying and we're flipping this. So the 18 goes in the numerator and the a goes in the denominator. Now I'm going to check for any numbers that I can divide by a common factor as long as one's in the numerator and one's in the denominator, and I notice that these have a common factor. I can divide both of these by 9. So I'm going to rewrite 2a to the 3rd. 9 divided by 9 is 1, times 18 divided by 9 is 2, and that's all over a. Now I'm ready to multiply straight across. So 2a to the 3rd times 2 is 4a to the 3rd, and 1 times a is a. So again, we're going to be using our rule for division that says if we're dividing and they have the same base, we're going to subtract the exponents. So 3 minus 1 would be 2. So I have 4a to the 2nd power. In the example that you do, you might need to use this rule here for the quotient, where if you have the same base and you're multiplying, you add the exponents.